Okay, ladies and gents, almost fell here. Just want to make sure it's on. Yeah. Right. So, guys, what are we going to do today? We learned last lesson how to calculate the determinant, and today we're going to look at certain properties of the determinant. And I've written actually them all through here, and I'll go through them one by one. Now, here's the thing that I'm not 100% sure. This is written in your textbook as a little investigation. It's not. It basically leads me to think that you don't actually have to remember these things. I don't, and I've looked at some questions, exam question. I couldn't really see any question where you're actually required to remember this because it's quite a lot to remember. What I'm sure you do need to know is to understand it and show it, but I don't think you need to remember it. Okay? And anyway, by going through all these properties, we're going to learn about certain things like transpose and things that we do need to know. Okay, so yeah, let's start with the first one. Determinant of A is equal to determinant of AT. Okay, what is that AT? Okay, I will explain. So let's start with a certain matrix. Let's say 1, -3, 2, and 0. Okay, and let's find out the determinant of A. Okay, I choose, and this whole lesson I'm only going to work with 2 by 2 just because it's easy. Okay, so but it's important to know that all these properties are also true for 3 by 3 and 4 by 4 and all kind of matrices. Okay, so I'm going to do 1 times 0 is 0 minus 3 times 2, so I'm getting plus 6. Hope I'm getting it right. Yeah, so the determinant of this is 6. Now, what is AT? AT, that T stands for transpose. Okay, transpose. And what is the transpose of a matrix? Okay, all we're doing is we imagine that we have a line that goes through here, the diagonal, and we're just flipping it. We're flipping it. Okay, so the 1s and 0, those numbers on the diagonal, they will stay in place, but these two numbers exchange sign. So that's going to be 2, and that's going to be -3. Okay, that's the transpose. Okay, and that is something you do need to know. We're going to use it in our next lesson. Okay, so all we're doing, we're exchanging those. If I have just, and I know I said I'm not going to use 3 by 3, but let's say just we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's say this is a matrix. Okay, now I'm going to write down here, I'll call that B. Okay? So just to make sure you understand what the transpose means, if I want to take this matrix and do the transpose, then I'm going to write, okay, 1, 5, 6. These are on the line, remain the same, but the 2 and the 4 swap places, okay? And the 3 and the 7 swap places, and the 6 and the 8, that should really be 9, isn't it? Just, I mean, it could be 6, let's just see that. So then the 6 and the 8 swaps places as well. Okay, so it's basically everything swap places. Not everything. You understand what I'm saying, okay? So that's the transpose, okay? Let me just erase this because we don't need that. Right, so what is the first property telling us? Telling us that the determinant of matrix is equal to the determinant of the transpose of the matrix, which is quite an interesting thing, and it's quite useful. All right, so let's just make sure that's right. Okay, so if this is AT, let's find out the determinant of AT. Okay, well, again, it's going to be 1 times 0 minus 2 times 3. Again, we get 6. So, voila, we tick this one. All right, let's pause and do the next example. Okay, let's have a look at the second property. Second property is telling us that if I take it multiplying a row or a column by k. So I've got a matrix 1, 2, 3, 4, and what we're looking at is we're making a new matrix, we'll call it A prime, by multiplying one of the column or one of the rows by a certain scalar k, by a certain number. So let's say we're going to multiply the first one by 2, okay? So I'm going to multiply just the first row, okay? I'll write it down like yeah, well, it will be 2, 4, 3, 4. Okay, so I left the second row the same. I just multiply the first row by 2. Okay, now what does this thing tell us? Tell us that the determinant of the new matrix is equal to the determinant of the old matrix times by that scalar, by that multiplication. So if I'm right here, I need to find out that the determinant of A prime, the determinant of the new matrix, should be 2 times the determinant of the first matrix, right? Because all I did is multiply one row by 2. Let's find out, okay? So the determinant of A is going to be 1 times 4 minus 2 times 3. It's, I think, minus 2. And the determinant of the new matrix is 2 times 4 is 8. 8 minus 12 is minus 4. And you can see that's correct, okay? So minus 4 is equal to 2 times minus 2. So it does work, okay? Now, if, for example, I gave you another C, and I'll write down C, okay? Which, let's say, after multiplying that by 2, first row, let's say now I multiply the second row by, I don't know, minus 1, okay? So the new matrix, okay, is going to be, so I multiply the first row by 2, let's say, and the second row by 1. So it's going to be minus 3, minus 4. So what this rule tells us, okay, I just want to make sure you can expand that rule, that what we're going to do here, we're going to multiply, basically we multiply the first row by a scalar 2 and the second row by a scalar minus 1. So it's going to be 2 times minus 1 times the determinant of A, okay, which is minus 2 times the determinant of A, which is minus 2, which is 4. Okay, so I just want to show you in this example that you can, okay, what happens if we multiply more than one row by a certain scalar? What do we do then? Well, we can carry on using it. We just multiply the determinant of the initial, the original matrix, the determinant of A. We time it every time by each scalar that we multiply each row. And you can see that actually this rule can really make our life much easier, especially with 3 by 3 or 4 by 4 matrix. Okay, if I have a certain determinant of A matrix, 4 by 4, and I know how much the determinant is, and then I multiply one row by 5, I don't need to calculate the whole determinant again. I just need to multiply 5 by the original determinant. So that's quite useful. Okay, let's move on to the next example. I'm just going to make a tick here. Here we go. Yes. Okay, our next operation, because these are all operations. I didn't use that word. We're messing around with our matrix and we're finding how the determinant changes. So the next operation is interchanging rows or columns. I'll do it for rows, but it's the same with columns. So let's say I have this matrix. Let's find out the determinant. Okay, minus 3 times, or minus 1 times 3 is minus 3, and that's 2 times 0, so it's just determinant is minus 3. Now, we're going to move on to a new matrix where I'm just swapping, interchanging rows and columns. So it's going to be 0, 3, minus 1, 2. Okay? So what does this rule tell me? It tells me that if I change the rows, okay, once, okay, then the determinant is exactly minus the other one. Okay? So, so really the determinant of A prime better be free, right? It should be free because it should be because I swapped the rows, so it needs to be minus 3. Let's see if it's free. 0 times 2 is 0. Minus 3 times minus 3 times minus 1, and the answer is 3, and it works. Okay. Now here's again, I'm expanding it. What happens if I can interchange more than one row? Okay. So, yeah, let's say I have a 3 by 3, then I swap row and 1 and 2, swap them, and then I swap row 2 and 3. What will happen there? Okay, well, I'm not going to show it to you in a 3 by 3, because it's going to take a bit longer, but let's just look at our example. Let's say I swap these rows, okay, I did swap them, and I got a new matrix, and the determinant is minus the original one. What will happen if I interchange it again? Okay, what will happen if I interchange a row again? Well, obviously you need to get your original, you will get your original matrix, right? If I swap that again, I'm going to get the original determinant, the original matrix. So I'm going to also get the original determinant. So I'm not, like I said, I'm not going to show it in 3 by 3, but you can practice that. Every time you swap a row, you time your, or column, you time the determinant by -1. So if you swap 2 rows, it doesn't have to be the same rows, okay? Here it's obviously the same rows. I don't have any other rows, it's just 2 by 2. But let's say on a 4 by 4, I swap the 1 and the 2, and the 3 and the 4, the determinant will be the same, okay? Tick, tick. Next. Okay, right, the next one is probably one of the most important one. I don't know if you're going to fully appreciate this really in this course. I don't think we get to that level, but that is later on when you learn this whole thing we're learning now is called linear algebra. In university, this course is going to be called linear algebra, matrices and all that stuff. If you have identical rows or identical columns, straight away you can tell that the determinant is 0. And in fact, a matrix that the determinant is 0, we can say that A is singular. Okay? Again, it's not something that is used in the textbook, but it is a really important concept when you're going to learn linear algebra in university. Yeah, we can say when the determinant of a matrix is 0, that means that the rows are identical. There are some identical rows there. Okay? I'm saying like this because sometimes you don't really see that the rows are identical. Okay, like it's hidden. But anyway, A is singular. Okay, so let's find out. Okay, I've got 2 identical rows. Okay, what's the determinant? 1 times 2 times 2 minus 1. Of course, it's 0. Okay, so that's sorted. All right, tick. Okay, the last property is to do with multiplying matrices, and if anything, actually, going through this property is going to help us remember how to multiply matrices, because that is probably it's a bit more difficult. Okay, so let's have a look at A and B. Okay, we've got 2 matrices. Let's just find out the determinant first. Okay, so the determinant of each one of them. So it's 1 times 0 is 0, minus is -2. And the determinant of B is -1 minus 2 is -3. Okay? Now the next step, let's call, let's say C is A times B. Okay? So in other words, the matrix C is 1, 2, 1, 0 times -1, 1, 2, 1. That's matrix C. What does the property tell us? It tells us that if you want to know the determinant of a product of 2 matrices, determinant of C in this case, well, that determinant is simply the determinant of A times the determinant of B. Okay, in word is the determinant of a product of matrices is a product of the determinant of matrices. Hopefully you got that, okay? But I can tell you now, I'll write it down here. Okay, before we even calculate C, I don't know what C is, we're going to do it in a second, but the determinant of C should simply be -2 times -3, it should be 6. So see how cool this property is? I can calculate the determinant of this matrix without even knowing what that matrix is. Okay, so let's try and find out this matrix and then find the determinant and see that it's actually 6. So you remember how to multiply matrices, okay? It's row times column, okay? Okay, so it's going to be also a matrix, a 4 by 4 matrix, and each entry is a row times a column. So your first entry, this one, is your first row times the second or the time the first column. What does it mean, row times column? It's 1 times -1. Okay, I'll do it in the head, guys, because we don't have enough space. So 1 times -1 is -1. Plus 2 times 2 is 4. Minus 1 plus 4 is 3. Okay? Next thing, what is this entry? Well, it's the first row, because we're still in the first row, times the second column. Okay? So it's 1 times 1 plus 2 times 1 is 1 plus 2 is 3 as well. Next, okay? Second row, first column will be second row times first column. And you see the pattern here, okay? Your first or second row, first column is going to be your first row, the second row times first column. So 1 times -1 is -1, plus 2 times 0 is just -1. And then the second row, second column will be second row times second column. 1 times 1 is 1, and then you've got a 0, so it's 1. Okay, so we've got C. And it took us a while, yeah? Now let's find out the determinant of C, and it better be 6, okay? Well, 3 times 1 is 3, minus 3 times -1 is 6, okay? It's 3 plus 3 is 6. So, tick, happy days, okay? So, like I said in the beginning, I'm pretty sure you don't need to remember all this. I haven't seen any questions, and it's kind of like a side note here, but you might be asked to show it, okay? So you might be asked to show that if you have these two, let's say these two matrices, that if you multiply together, the determinant of this product of these matrices is equal to the product of the determinant of each one of them. And now we've gone through this, and at the same time, we learned about how to calculate the transpose of the matrix, which we will need for our next lesson, I think. Right, chill. I mean, have a lovely afternoon.